This is 1.3, absolute value equations and inequalities. When we are solving an absolute value equation, we want to isolate the absolute value first. So before we do anything else, we want to get the absolute value by itself. So on this one, we're going to start by subtracting 4 from both sides, so that we have 3, and then the absolute value of x minus 2 equals 6. Divide both sides by 3, so we have x minus 2, and the absolute value of r still equals 6. Now after we isolate or get the absolute value completely by itself, then we're going to write two equations. So step 2 is to write two equations. The equations are, this part in here is called the argument. So we take the argument, x minus 2 equals 6. Then our second equation is also x minus 2, that's the same each time, but it's going to equal, oh my goodness, 6 divided by 3 is not 6. Did you guys catch that? Hopefully you did. That's 2. So this is going to be 2. Good golly. All right, so we have x minus 2, the absolute value of x minus 2 equals 2. So we rewrite it as x minus 2 equals 2, and x minus 2 equals negative 2. So the argument stays the same each time, it's just what it equal to. One is positive, one is negative. And then you solve. So we're going to add 2. So we have x equals 4, and we're going to add 2. So we have x equals 0. So we have two answers, x equals 0 and x equals 4 will both make that statement true. So go ahead and write down number 2, push pause, solve it, and then come back and see if you got that right. Hopefully I'll do it right this time. So plus 6, negative 4, absolute value, 2x minus 3 equals negative 4. Divide both sides by negative 4. So we have absolute value of 2x minus 3 equals a positive 1. Then I'm going to write my two equations. 2x minus 3 equals a positive 1, and 2x minus 3 equals a negative 1. Then I'll solve both of those. 2x equals 4, divide by 2, x equals 2. Still adding 3, 2x equals 2, divide by 2, x equals 1. So we have 2 and 1 as our two answers. All right, same thing on number 3, trying to get the absolute value by itself. Start by adding 8 to both sides. So we have negative 5, absolute value x plus 6 equals 30. Divide both sides by negative 5. Absolute value of x plus 6 equals negative 6. Now here we run into trouble. Absolute value has to be positive. Absolute value represents a distance away from 0. So if you're saying that absolute value is equal to a negative number, that can't be. So on this one, anytime an absolute value equals a negative number, we say no solution. So you don't even write the two equations, you just stop right there and say no solution, because we have to be equal to a positive number. All right, now let's try some absolute value inequalities. We're going to do the same things, write the two expressions, but we're also going to add in graphing on the number line and writing our final answer in interval notation like we did in our previous inequality solving sections. So just like before, we want to write two equations. X plus 5 is less than or equal to 8. So basically the same thing that's written there, just without the absolute value bars. And then x plus 5, in your second equation, you're going to flip the inequality sign when you put the negative number there. And then solve. So we're going to subtract 5. X is less than or equal to 3. Subtract 5. X is greater than or equal to negative 13. Okay, so those are the two inequalities. We're going to take those and put them on a number line. Remember, our smallest one always needs to go on the left. It has an equal to sign, so that means we have a closed circle. And then, so does the 3, it has an equal to sign, closed circle. X is less than or equal to 3 means we're going to shade everything to the left. X is greater than or equal to negative 13 means we're going to shade everything to the right. And now if you remember from before, we had words like and or to tell us if we were looking for everything or for the overlap. Well, there's no words here to tell us what we're looking for. So we have to look at the inequality. So since this started off as a less than, that and part tells us that we're going to use, it's the same as an and. And so remember, and means overlap. So we are looking for where those overlap each other, which is right here in the middle, that section there. So we'd say bracket, because it's a closed circle, negative 13 to 3, bracket. If it was a greater than sign, greater, kind of like this next one, here's a greater than. So they mean greater is or, and it means that we are looking for everything. So everything that is shaded. So in that case, if that first one was a greater than sign, we would say negative infinity to positive infinity. Let's see how number 5 works out. All right, we're going to start by isolating the absolute value. So we're going to divide both sides by negative 3. So we have x minus 2 in the absolute value. Since we divided by a negative, we have to switch the inequality sign. And we get a negative 2. Is it possible for a positive number, because remember absolute value always indicates a positive number, is it possible for that to be a positive number to be less than or equal to negative 2? Nope, there are no positive numbers that are less than negative numbers. So here we have another case of no solution. So always got to remember that absolute value means a positive number. Let's take a look at another one. Number 6. Divide both sides by negative 3. So you have x minus 2. Again, we're going to change the sign since we divided by a negative. Negative 2. So this is the same problem we just did. It's just that we're starting off with a less than, whereas before we started off with a greater than. What that does is it allows us to actually continue solving, because is a positive number greater than a negative number? Well, always that is. So remember, all real numbers would work for this inequality. Now, when it's all real numbers, we can actually graph that on a number line. When it's no solution, there's nothing to graph. But all real numbers means we'd shade in the entire number line. And in interval notation, we would represent that as negative infinity to positive infinity. All right, number 7 is our last one. Go ahead and give it a try. Push pause, solve it out, come back and check it. We want to start by isolating the absolute value. So we're going to add 3. 2x minus 5 is less than or equal to 10. Then we're going to write the two equations. So we have 2x minus 5 is less than or equal to 10, just like it's written, but without the absolute value. But also 2x minus 5 is greater than or equal to negative 10. Now please write out the two equations before you do any solving, because sometimes if you only write one and solve it, you forget to go back and write the second one. So write them out first, then solve them. All right, so we add 5, and then we have x is less than or equal to 7.5, add 5 on this side, and we have x is greater than or equal to negative 2.5. All right, we got to go to our number line, put those values on there. Lowest one on the left, so negative 2.5 goes on the left. It was a closed circle because of the equal to underneath there. 7.5 is also a closed circle. All right, it says x is less than or equal to 7.5, so that's going to the left. X is greater than or equal to negative 2.5. So the graph kind of looks very similar to number 4 that we did. So since it's less than, our original was a less than, that means an and. So we're looking for the overlap. So that would be bracket negative 2.5, 7.5 bracket. Ta-da! And that's all to 1.3, solving with absolute value. Just remember to get the absolute value isolated first and to write two equations before you solve it.